Hey everybody, this is Mr. Oliver. I'm going to go through the solutions on the AP Physics 1 Unit 1 practice. So feel free to pause or fast forward at any point if you don't need to know the information, but otherwise let's go ahead and get started. All right, so for this first question, it asks, what is the SI base unit for mass? Well, this is just kind of a piece of knowledge information. Number one is going to be C. The kilogram is the base unit. For number two, a bird is traveling at constant speed. Which of the following situation requires a bird to accelerate? For this question, the answer has to be choice E. The bird has to fly in a circle. So the way you know that this is the truth is that in order to accelerate, acceleration is a change in velocity with respect to time. And so if the velocity changes, then you're accelerating. Well, how can you have something that has a changing velocity if it's at constant speed? Well, remember, velocity is a vector quantity, so it has a direction to it, and that means that if the direction changes, then even if you're moving at a constant speed, then you technically will be accelerating. So any kind of circular type of motion at constant speed is considered to have an acceleration. Specifically, this would be a centripetal acceleration because you're going in a circle. All right. For questions 3 and 4, you're referring to this graph of position versus time. Now, on a position versus time graph, we can find out information about the velocity or the speed, depending on the question, based on the slope of the line. And so this question asks, where does it have the highest speed? Well, the highest speed would occur where it has the largest slope, even if it's negative. So during segment DE, this is where it have the largest slope, and so therefore choice B would be your answer. Largest slope means largest velocity. So slope of a position versus time graph is the velocity or the speed, depending on the circumstances. All right. For question 4, where does it change its direction of motion? Well, if you're talking about a direction, then you need to be considering the velocity because the velocity has direction. And so if you look on the graph, segment CD as well as AB have a positive slope. So these segments right here mean it's moving in a positive direction. But segment DE has a negative slope, so that's where it's moving in a negative direction. And so its direction of motion changes whenever that slope goes from a positive to a negative. So that question, the answer for that question is C. It occurs at 5 seconds whenever that slope changes. Question 5 asks about the displacement. The displacement of a particle does not depend on A, the distance. Because the displacement, if I had this picture right here and I went from P to Q, the displacement would technically be a line that starts at P, goes to Q, and it's the shortest straight line distance between P and Q. So it does depend on the shortest distance. It does depend on the location of P, it does depend on the location of Q, and it does depend on this direction. So everything I use to draw this red line, I need to know that. I don't care about this little curvy pathway to get there when I'm talking about the displacement. Remember, displacement and distance are different. Alrighty, question number 6 talks about a postal worker walking 161 meters due east. So let's say we start here. Here's his truck. This is where he's starting at. And he's going to walk 161 meters due east. So that means he's going to be going to the right if we consider a north-south coordinate system, north, south, west, east. So he's going to walk 161 meters to the right on this diagram. And then he's going to turn around and walk 194 meters from where he turned around. So that means he's going to take this route coming back and go 194 meters. And so the question asks, what is his displacement relative to his truck? Well, you take the beginning point, which is right here where his truck is, and back to the ending point, that would be a displacement of 33 meters, because I just took the difference between these two numbers, and it's pointing west. So that's going to be his displacement, 33 meters due west. Okay, so moving on to question 7. A race car travels at constant speed around a track, and he's going to go halfway around the track. So that means that if I started at any point, it doesn't matter where I start on this circular track, that if I start here and I go halfway around, it's going to end exactly on the opposite side of the track. And so the question is, what is the displacement? The displacement is, like I said before, always a straight line path between where you start and where you end. And so that displacement would be the magnitude of that displacement is just going to be the length of that arrow. In this case, it's 2 times the radius, 2r. So D is your choice for number 7. Number 8 asks about average velocity. Average velocity is a little bit different than just regular velocity. Average velocity is the total displacement, not distance, total displacement divided by the total time. So in this particular case, it's saying the time interval between 15 and 35 seconds. And so what I'm going to do is I'm going to pick a point at 15 seconds, which is right here, and 35 seconds, which is up here. We'll just say it's at that intersection there. And so the average of displacement is the total displacement between this point and this point. So that's at 30 meters here, and this is at 70 meters. So this thing is moving upwards 40 meters. That's the total displacement, 70 minus 30. And then the total time is 35 seconds minus 15 seconds, which of course is 20 seconds. And so for this case, it's 2 meters per second. Now, another way that you can do average velocity is just take the slope of the line between the 2 points. The slope of a position versus time graph, because this is a height, it's a position. Between any 2 points, the slope is the average velocity. Number 9, which is also a base unit. This goes back to the just kind of knowledge of what the SI base units are. The ampere is a base unit. If we want to go through them again, the 7 base units are the meter, the second, the kilogram, the ampere, the mole, Kelvin for temperature. And the last one's kind of weird. It's called a candela. It's just a number that measures how bright something is, the luminous intensity. And so for number 9, the answer is also D. Number 8 was A, by the way. All right. A particle has a mass of 1 milligram. Well, this is a SI prefix thing. A milli is just 10 to the minus 3. So if you see a milligram, all you're doing is converting it to 10 to the minus 3 grams. So 10 to the minus 3 grams is answer choice number letter C right here. So just make sure you go back and look at your unit conversions. And guys, on your AP test, you will get to have your formula sheet on there, and the formula sheet on the back has that table of information with your metric prefixes and all that stuff. So it's not something you got to memorize, but it is something that you need to be able to work with. All right, number 11, we've got a velocity versus time graph. And so this question asks, at what time after t equals 0 does the object again pass through its initial position? So what we need to do is when you say, well, how do you get the position from a velocity graph? Well, you don't really get position, but you do get a change in position, otherwise known as the displacement. And you can get that by taking the area under, oops, if I can spell the word under the graph. And so what I'm going to do is to say, okay, well, this area down here, this little triangle, has an area of 1/2 base times height, and it ends up being 0.5 meters. Now, because it's below the axis, below the time axis, that's actually going to be a negative area. So this object is starting off by moving backwards 1/2 meter. And so in order to get back to its original position, it has to stop, which it does right here, turn around, and you can tell that it turns around because the velocity then becomes positive. It's above the axis. And then progress forward 0.5 meters. And so that's not going to happen at 2. It's actually going to happen somewhere in here, somewhere between 1 and 2 seconds, when this area would equal that area. And so whenever the positive area, positive 0.5, equals negative 0.5, that's when it's reached its original position. In other words, when the delta x is equal to 0. The area is equal to 0, total area. And so that happens between 1 and 2 seconds. So this answer is C. All right, number 12, a body moves in a constant positive direction at a constant speed for 24 meters. Okay, so this graph does not go with question number 12. It's actually on for the next question. So ignore this. So for number 12, between 0 and 1 second, it's moving at a rate of 24 meters per second. So if you're moving 24 meters per second for 1 second, that means you've moved 24 meters. That's how far your displacement is. And then at 1 second, the body has a constant acceleration of 6 meters per second squared. So when you see constant acceleration, remember, you need to be using kinematics. So a kinematic relationship that describes position, I could use this one. X is equal to x naught plus v naught t plus 1/2 a t squared. All right, so now we already know what the initial position is. It's 24 meters. Now the velocity during this time is the same velocity, or the initial velocity is the same velocity which you started with. So if you're moving at 24 meters per second, it's not that you stopped and then started speeding up again. You've already got a constant velocity. So this v naught is 24 meters per second. But now he's going to accelerate until we get to time 11 seconds. So does that mean that this t right here is 11? No, it doesn't. It means that he's going to be moving for 10 more seconds, because 1 second is kind of technically where this kind of acceleration started. So that time is going to be 10. And then, of course, the acceleration is 6 meters per second squared, move at a time of 10 seconds. And so to calculate our final position, we're going to do some mathematics, get your calculator, and plug those numbers in. And you end up getting a kind of a weird number. You end up getting negative 36 meters. It's not that you moved negative 36, it's just that your final position is 36 meters behind where you started. Right? And the reason why I know it's going to be, I made a mistake here. This acceleration is in the negative x direction, so I should have put a -6 right here for the acceleration. Sorry about that. All right, moving on. Number 13, the displacement corresponds to this graph from the previous question. It's a linear graph. So let me just kind of sketch that up here. Position versus time. And so the displacement of an object moving along an x-axis is shown as a function of time. So anytime you see the position versus time graph as being linear, then that means that the velocity, which is the slope, is equal to a constant value because that slope is the same the entire time. Now, what has to happen in order to get the acceleration, we would need to take the slope of a velocity time graph. But it's obvious since the thing is at a constant velocity, it is not accelerating. So therefore, it must be zero acceleration. Number 14, here's another kinematics kind of style question. In this particular case, you're given some information that it's released from rest, so V naught is equal to 0. It falls for 3 meters, so I would say my displacement is negative 3 meters. And what we're looking for is the acceleration of that object. And the acceleration due to gravity specifically, but that's what we're looking for. And so let me just come over here on a blank sheet of paper so I can work this out. I would say that my position or my displacement is equal to V naught t plus 1/2 AT squared. Because the initial velocity is 0, that term goes away. My displacement here is negative 3, 1/2 times A times 1 second, because it says it's falling freely for 3 meters in the first second, so my time is only 1 second. And so you can do the algebra yourself, but the acceleration ends up being negative 6 meters per second squared. And so that corresponds to choice C. All right. Question 15 is a good question that kind of shows the multiple different options for velocity and acceleration graphs. So for one that's being dropped from rest, if it drops from rest, that means the initial velocity has to be 0. And in this case, it's an easy series of elimination. Every one of these, choice A, B, C, and E, have an initial velocity. So the only choice left is D, because the initial velocity here is 0. And you would also know that because it's under free fall, the acceleration would have to be a negative acceleration. That would correspond to choice C and D, but the only one that fits for us is choice D. All right, number 16 is another kinematics equation kind of problem. This is simple enough. Delta x is equal to 1/2 AT squared. So it's 1/2 times 5 times 2 squared, which is 10 meters. Choice A. If number 17, a car is traveling to the east and starting to slow down, well, anytime anything that's moving in one direction with a velocity, but it's slowing down, that just means that there has to be some kind of a force pushing on it to the left. Well, let's say it's a car, you're probably going to have some friction between your tires and the road, and that acceleration or that force is going to provide an acceleration to the left. And so the acceleration has to be, number 17, B, acceleration in the negative x direction. It's the only way that that car can slow down. Now you don't know that the acceleration is decreasing or increasing. You don't necessarily know that. But the only one that must be correct, is it has to be in the negative x direction. The only way that you could increase the acceleration is if you push the brakes down harder and it causes the brakes to engage and create more friction and make the acceleration get bigger. Or if you kind of let off of the brakes a little bit, not necessarily completely disengaging them, but making the pressure on your brakes a little bit less, yeah, you could decrease that. But like I said, you don't know the circumstances of the problem without more information. But the only thing you know must be true is it has to be in the negative x direction. Right? Question B talks about throwing something straight up in the air. So if I launch some kind of a projectile or just toss a ball straight up in the air, the only thing that you know is that during the entire time of flight, as soon as you let it go, that object, as it goes up and comes back down, regardless of where it's at, the acceleration on that object always, always, always is down because the acceleration due to gravity is down. So at the highest point it's down, midway up the acceleration's down, all these accelerations are always down. Even in number 9, if you throw a ball downward, say I'm up here on top of this tower, and I take a ball and I physically force it down, yeah, during that time that I'm pushing it, there's a little bit bigger, stronger acceleration. But you know that after it's been released, as it's falling, the acceleration must be down because gravity is down. And so number 19 is B. It's constant, not necessarily down, but the acceleration is constant because of gravity. Gravity doesn't change. Acceleration doesn't change. All right. Number 19 was done. Number 20. An object is moving with constant velocity in the positive x direction, the position versus time graph. Kind of a knowledge-based thing. If you're moving with constant, non-zero velocity, just means that it's not accelerating, it's a constant velocity. And so if your position time graph has to be a linear increase. And so your constant velocity would represent on a position time graph by making a straight line upward at an angle with the time axis, C. If you're accelerating with a constant acceleration, the position time graph would be a parabola. But the velocity time graph is the one that's going to be linear. Your speed is steadily increasing every second. That's what a constant acceleration means. And so this is also a straight line making an upward angle with the time axis. And then here's kind of another fact-based kind of question. The slope of a velocity time graph. Velocity time graph. If I take that slope, that gives me the acceleration. All right. Number 23 is a projectile problem. Actually, 23 and 24 both. How do the speeds of the ball compare at the 3 points? Well, if you're talking about the speed, right here, the speed is a combination of both the horizontal and the vertical velocities. So at any point in time, if you said, hey, what's the speed of this projectile? I would say that it's the total velocity. And how would you calculate that? Well, you'd calculate by taking the two components of velocity and kind of Pythagorean theorem it. Take the horizontal component squared plus the vertical component squared, and that would give you, and take the square root of that, and that would give you the speed. So, question is, point Q is the highest point, points P and R at the same height, so P and R are at the same elevation. How do the speeds compare? Well, if I'm going up at this location and down at this location, because of that symmetry and that nice little symmetrical parabola, P and Q have to have the same speed. And it has to be bigger than at Q, because at Q, there's only a horizontal component of velocity. If you remember, for a projectile moving in 2 dimensions, that value is constant. So, because it's not moving up or down, this Vy term would be 0 at Q. And so it's actually moving the slowest there. So choice D has to be the answer. Which of the following diagrams best shows the direction of the acceleration? Well, just like I said before, if you're in free fall, projectile motion, any of those things, acceleration is always down, always down, always down. Wherever that object is moving, even right before it hits the ground, even at the instant it hits the ground, it's still acceleration of down of 9.81. Now, of course, the ground could provide a force, but as far as that freely falling object right before it hits, it's still acceleration 9.81 meters per second down. So the answer choice is E. All right, this next question shows a horizontally launched projectile. Guys, I would gander to say that this kind of a question, if they're going to do a projectile question, would be a horizontally launched projectile. Probably not a parabolic, but that kind of question shows up a bunch. So for this diagram here, here's the question. It says, how much time does it take to hit the ground? Well, that's pretty simple. Remember that when a projectile falls downward, the vertical components of time and velocity and everything are independent of the horizontal components. So even if I just drop this rock straight down, the time it takes to hit in both cases are the same. And so in order to calculate that, delta y is equal to v naught yt plus 1/2 at squared. That's a good kinematic equation to use. Delta y in this case is going to be h. V naught y is the vertical component of velocity, but since it's launched horizontally, this term is 0. And so the last thing we have is 1/2 a. Well, a is of course going to be the acceleration due to gravity, so it's gt squared. And so solving for time, it's going to be 2h over g, and take the square root. And so that choice is E right here. Okay, number 26. Number 26 has a question talking about acceleration due to gravity. Object thrown upward, acceleration due to gravity has to be down and it has to be constant. So number 26 is E. If it's thrown horizontally, what about acceleration? Doesn't matter. Downward and constant, always. If you shot an arrow and it has two components of velocity, you're going to be shooting it at some kind of an angle with a speed v0, but the horizontal component is 30 units, 30 meters per second, and a vertical component will be 40 meters per second. So if I want to find the total speed or the total initial speed of the arrow, right here, initial speed of the arrow, I'm looking for this term. And so that's just, you do Pythagorean theorem here. 30 squared plus 40 squared, take the square root of that, is 50 squared. And that's just a 3, 4, 5 right triangle. It's an easy way to figure that out. Now, what is the speed of the arrow when it's highest point? And so that's kind of going back to that projectile. Anytime you're at its highest point in its trajectory, it's only moving horizontally. So the speed here is how fast it's moving horizontally, which, because that value is constant, is the same as the horizontal velocity component. And in this case, that's 30 meters per second. So also choice E. All right, kind of going back, this question kind of snuck in. The displacement of a particle is less than, or it could be equal to, the distance that it's traveled to. So the displacement is always the shortest distance between 2 points. So it's at the very minimum, it's got to be smaller than, but it could also be the same value. All right, question 31. If you've got two vectors and they're going to be added together, if I have vector A and I have another vector B and I stick them together, remember you always got to add these things kind of one thing after another. They call it tip to tail. So like if I walk 10 meters to the right and 20 meters up, I have to do them in order. And in this question it says that when I add these two together, I get this third vector, vector C. And it says if I get this relationship, a squared plus b squared equals c squared, the only way that has to be true is if those two vectors A and B are at right angles to each other. And so that's choice A. All right, guys, we're almost done. We've got about 6 questions left. So for general projectile motion with no air resistance, the horizontal component of a projectile's velocity remains constant. That's a pretty significant fact that you got to remember, that throughout the flight of a projectile, that at any point in time, anywhere along that flight path, the horizontal component, v0x, that value stays the same all the time. It's always the same speed. And the reason why, of course, is because there's no forces to push it back that way. There's no gravity pulling it to the left. And when you're doing projectile motion, you're assuming that there's no air resistance, so there's nothing to slow it down. Now, if there was air resistance, yeah, that value would change a little bit, and that parabola would kind of end up being shorter in distance and in height. But for general projectile motion, when we assume there's no air resistance, you have to assume that these horizontal velocities are always the same. Choice B. Now the vertical component of the acceleration does change. It starts off at a high value, becomes 0 at the top, and then turns around and speeds up on the way down. So it first decreases on the way up and then increases coming back down. All right. Now 34, you've got a pebble thrown horizontally and another pebble dropped from the same height. So this is kind of like where you've got one object that falls straight down and another object that's launched horizontally. So it's going to take this kind of parabolic path down. This is kind of similar to that Mythbusters video that we watched that had the bullet drop experimental setup. And sure enough, these two times are equal. And the reason why is because only acceleration due to gravity pulls it to the ground. And so they have to hit at the same time. Now, if this pebble was thrown down, let's say someone came up here and actually physically threw it down, of course it's going to hit the ground first. But in a free fall scenario, they have to be the same. All right. At its highest point of trajectory, for this particular question, they're asking about the velocity and the acceleration. So if I take that kind of trajectory and I'll look at it again, at this highest point, it's going to have an acceleration downwards, and the speed or the velocity of that projectile is only going to be horizontally. And so at its highest point, these two things are at right angles to each other. Right? The ball's acceleration is down, and the velocity is moving to the right. So for this question, the answer has to be B. Neither the ball's velocity nor its acceleration are 0. The vertical velocity is 0, but the total ball velocity is definitely not 0. It's still moving. 36. This question does not belong to this. So we've got, this is just kind of a little problem talking about vectors and angles and stuff. And it says it rolls down along a mountainside at 7 meters per second. So it's moving, I guess that's a car. It's moving this way at V is 7 meters per second. And the horizontal component of its velocity is 1.8. Here, let me do this on this blank page over here. So it's moving down this way at 7 meters per second. The horizontal component of its velocity, this component right here, is 1.8, and it wants to know the angle of the mountain. So we're talking about this angle right here, this angle theta. And I guess I drew this incorrectly to scale. It should be more like this. That's a pretty steep mountain. So this is just a little trig problem. Calculate what the angle theta is. So this is the adjacent side, that's the hypotenuse. So cosine of theta is 1.8 over 7. So that means theta is the inverse cosine of 1.8 over 7. And so therefore theta has to be 75 degrees. Yeah, 75 degrees. Which is choice A. And then the last one, which of the following would be accurate representations of the horizontal velocity, vertical velocity, and acceleration at point P? So let's just draw those real quick. It's going to have a horizontal horizontal velocity Vx. It's going to have a vertical velocity going down Vy, and it's also going to have an acceleration also down A. And so that corresponds to answer choice A. All right, guys, that concludes the solutions for the Unit 1 practice. If you have any questions, just be sure to email me, and I will talk to you later. Thank you.